Hello learners. So in this session we will study about the association rules using R. So we'll also study about the algorithm that will help us in understanding the association rules and also help us understand what are the association between various elements. Okay. So association rule mining in R language again is an unsupervised non-linear algorithm to discover how any item is associated with other. So what happens in there is that there will be various kinds of products because it is basically used for product marketing. And what happens is that you have to find out that which particular type of products are being purchased together or they are being used together. So this is one of the biggest application of association rule mining. So you will be able to generate various rules based on that. Again, if you mine for a certain number of times, you will understand that certain items appear together, and based on that their major use lies in retail sector, in grocery stores, in online platform, and those who are having that they are used where the database is very large. So suppose you have 1 TB of data, like you have 1 TB of CSV files worth of data of customers thinking that they are purchasing different items. So it is very difficult to find out which particular, how to link it, how to make that data meaningful, because if the data is very big, so you have to analyze that data to understand the relationship between the data. But because the data is so much big that there is no such algorithm exist for it that can just directly print out the relationship between various columns and various predictor variable and response variable. Because when the data becomes large, its dimension becomes large, and most of the time machine learning will not be able to handle that part. So in unsupervised approach, if you used unsupervised approach, the main part here is that you will not be able to do the learning part. But if you use a certain aggregation method, like because we are using an unsupervised approach, so it means that there is no wastage of time in training. So it means that if there is like 1 TB of data that is being with you, so you require if the column, the dimensions of the data is very high, so it will require around 1 to 2 or 3 days to train on that data. So that is why we do not prefer to go that way, but we have to find out if there is any kind of relationship that exists in the big data. So what do we do? So here association rule mining can come handy. So it has various algorithms, it has very simple algorithms, but there are few things to understand why it is being used in retail sector or in any marketing purposes it is being used. So suppose you have a very big data set that is being present here. So you have to figure out that in which particular in which 2 or 3 particular items are brought frequently together. Then this association rule mining will be able to mine something meaningful, because if you have very big data, you will not be able to directly mine it by looking at it. You cannot be able to figure out that which particular items are brought together. But if you apply a certain algorithm for it, then you will be able to easily figure out that which particular items are brought together. So that is why if you seen in the Amazon, the example of Amazon web page, if you go on to any shopping site also, if you go on to a shopping website, when you click on a link and you are purchasing a certain item, and then there is a tab that is at the end of the page that will say that frequently bought together item. So they will Suppose if you are buying a phone, so when you press add to cart, it will show you options to buy back cover of that phone or buy screen guard of that phone. So these are frequently purchased items that are purchased together. So that is why the algorithm of that particular website is showing you that this particular items can be brought together. So what happens is that because it is a frequently brought item that are brought together, so what the user do, it can easily simply add that items to the cart. So this will also help the shopping customer, but will also help the website or any business to make more money. So because it will also save on resources, because suppose you have purchased a phone and you have ordered it and it is being shipped. After that you remember that I need a screen guard as well as a back cover of that phone. So you will again order it, but that order will arrive separately. So you see here that when you place it together, these items, when you are buying a phone, you are also saving resources to the website as well, because they will not be shipped differently, they will be shipped together, and you can save time as well as company's money can also be saved. So this is again a win-win situation for the customer as well as for the businesses as well. So there are three common terms that you have to understand how to measure the association. So three terms are support, confidence and lift. So what is the meaning of support, confidence, and what is a lift measure? So if suppose if you are assuming first example that you are buying a product A, second example is you are buying a product B. So the rule, the support is P of E1 and E2. So E1 is byproduct A, E2 is byproduct B. So this is the probability of, the support is the probability of buying both the products A and B. So this is what I am saying, that frequently brought together items. So support will tell you that the probability, if you write P of E1 and E2, E1 stands for product A and E2 stands for product B. So the probability of buying both the products A and B is referred to as support. Another one is confidence. So confidence is that you can say P of E2 by E1. So what it means is that E2 item stands for item B and E1 item stands for item A. So what is this means? This is referred to as the confidence, probability of buying the product B given that the product A has already been bought. So what it means is that you have already bought the product A. Now what is the probability that you will click on the other product and you buy it, because they are frequently bought together item. So what is the probability that you will buy the second product after buying the first product? Similarly, interpretation, how can you interpret support and confidence? So suppose you have bought a new computer, and with that new computer you will also bought a antivirus software or a Word or Excel or a PowerPoint, that is a office suite. So suppose when you are buying a computer, you will also buying with it the antivirus software. The support for it is 2 and the confidence here is 60%. So support 2 means that 2% of the transaction under analysis that shows that computer and antivirus software are purchased together. So this is how support will work, and confidence will show that 60% of the customer who have purchased a computer has also bought the antivirus software. So this is the confidence, the meaning of the confidence. So support and confidence are two separate terms. Support says that what is the probability of buying a product, both the product A and B, and confidence says that the probability of buying the product B given that the product A is already being bought. So the support here for antivirus and computer, so they 2% support is there. So it means 2% of all the transaction under analysis shows that computer and antivirus softwares are bought together. And what is the confidence? So 60% of the customer who have purchased a computer have also purchased the antivirus. So it is just different meaning if you understand, and it has separate meaning of both of the things. So support and confidence are different of each other. Okay, so they are different, not the same thing. So brought together, and probability of getting the item B, assuming that item A has already been purchased. Okay. Now another measure is referred to as lift. So a measure of association, that is the occurrence of the item set A, is independent of the occurrence of item set B if. So it is represented as P of A and B equal to P of A dot P of B. So P stands for probability. So P of A and B is equal to 1. Now if P of A dot P of B, so if P of A dot P of B is less than 1, so it means if buying A and buying B are negatively associated. So if the value of P of A and B is less than 1. So if the value of P of A and B is equal to 1, it means that they are not associated. The buying of A and B are not associated at all. But if it is greater than equal to 1, it means that they are positively associated. It means that if you have buying both the product A, you are also buying the product B, so it means that there is much more chance of buying a product A, and B. You can think of it like that, they can be bought together. So a measure of association, that the occurrence of the item A is independent of the occurrence of the item B only if you will see P of A and B equal to P of A dot P of B. So the value is dependent upon the value that you will get. So either it will be negatively associated, either it will be not associated at all, or it will be positively associated. So that depends upon the calculation of lift. So this is how lift is being calculated. So after that we will come to the how to see this association rule mining in R. So you can install a package that is A rules, and another package that you can install is arules.viz. Okay, aruleviz followed by wviz, and then the syntax is very simple. So association rules are given as a priori algorithm. So it is based on a priori algorithm. I'll tell you what a priori algorithm is. So data is given to you, then there are parameters, and in the parameter list you are given support and confidence. So if you see here, first you install the package, then you import the package arules, arules.viz, and then you're taking the data as groceries. So groceries, because association rules can also be employed in case of retail selling or in case of marketing. So that is why it is being, the data set that is being used here is grocery. Again, grocery data set is a inbuilt data set of R. So you directly write data equal to groceries in quotes. You will be able to get the data in the R workspace. So you can print the data what are there. So you can write inspect to check the variables of the data. So the items here that are listed here are citrus fruit, semi finished bread, ready soups, as well as some other items as tropical fruit, yogurt and coffee. So there are a list of it. So these are the items that are there. So you can simply apply a priori algorithm to just replace the data with the grocery data, and you can simply write the parameter where support is given as 0.01 and the confidence is given as 0.5. So a priori algorithm will start working and it will give you the result. Okay. So what is a priori algorithm? How it is being dealt with? How the algorithm works? So firstly, I will tell you about this, and then I'll return to this particular slide what actually is happening and what are the results. So a priori algorithm is basically used for setting the association rules. So you will be able to figure out what are the association rules and how to generate association rules by using a priori algorithm. But firstly, when you are using the algorithm, you have to set the minimal support and minimal confidence value. That is the first step in a priori algorithm. The second step is that you should take any and all supports in the transaction that are worth more than the minimum or chosen support value. So I'll tell you what do I mean by this, because when we'll solve the when I solve some example, you will be better able to grasp this particular statement. Now in the end, you have to identify any rules in this subset that have a confidence value greater than the threshold or minimal confidence. After that, you will arrange the values or arrange the rules from most restrictive to least restrictive. What do I mean by this? So step by step I'll go. So suppose firstly you are taking data. So the transaction values are given here 100, 200, 300, 400, and the items that are bought together are 135. So you can think of this like they are grocery items. So 1 is bread, 3 is eggs, and 4 is something like tea. Okay, so these 3 items are brought together. So transaction 200, 235 is that similar way. Transaction 300, 1235, and transaction 400 and 25. So what it means is that transaction is the number that is given to a particular transaction, and the items that are bought together. So 1, 3, 4 are different items. So the first step is to set the minimum support value and the threshold confidence. So what we have set the minimum support to be 50% and threshold confidence to be 70%. So understand what is the meaning of minimum support, understand what is the meaning of confidence. So remember, how the items are bought together is support, and confidence is when one item is bought, what is the probability of buying the other item. So this is how support and confidence will work. Okay, so moving on forward, you check. Now first thing is yet the item set is written as 1, 2, 3, 4, 5. So the first step is the item set is written that 1, 2, 3, 4, 5. Now you see here how many times the one item set is repeated, because in this particular example we can see that there are 4 items that are being bought. So out of the total items that are being there, how many single item is placed. So you check here, 1 is present in the transaction 100 and 1 is also present in the transaction 300. So there are total 4 transactions. So 2 out of 4 transactions. So it means the support is 50%. So what it means is that 2 item is being purchased, first item, 1 item is being purchased 50%. So something like that. In the similar way, check for the item 2. Now check the item 2 is present in the transaction 200, 300 and 400. So it is 3 by 4. So the support here will be 75%. Similarly, the 3 item is present in 100 transaction, 200 transaction and 300 transaction. So it is again 3 by 4, and the transaction and the item 4 is present only one time, that is in 100 transactions. So it will become 1 by 4, and then the item 5 is also present in 3 separate transactions, that is 200, 300 and 400. So it will again become 3 by 4. So when you check here why this 1 by 4 is highlighted, that is of only 25%, because we have 5 items. out of 5 items, only one item has a below threshold value of 50% support. So we have already set the minimum support threshold to be 50%, and if you check it, the fourth item, that is the 1 by 4, the fourth item is only in the transaction 100, so it becomes 1 by 4, so it is 25%. So because we have set the support to be at least 50%, so you can delete the item which have a less value. Similarly, now in the next step, you create a combination of these items and you again figure out the support value. So now check, suppose now check in how many patterns that you can form. So with 1, 2 a pair, one pair can be formed if you combine 1 and 2, then 1 and 3, then 1 and 5, because you cannot take 1 and 4 because that is already being deleted because it does not have a minimum support. So another pair that can be formed is 2, 3 and 3, 5. 2, 3, 2, 5 and 3, 5. So these are the 3 other pairs that can be formed. Again check the same thing. Now 1 and 2 to be placed together, check in the transaction, the table, that is the initial table, check where 1, 2 comes together in the transaction. So 1, 2 come only in the transaction 300 one time out of 4, so it becomes 1 by 4. So it becomes 1 by 4. In the similar way, another item, another 1, 3 comes 2 times, that is in the transaction 100 and 300, so it becomes 2 by 4, which is 50%. And 1, 5 only comes at transaction 300, so it only becomes 1 by 4. Similarly for 2, 3, it also comes 2 times in transaction 200 and 300, so it becomes 2 by 4. And 2, 5 also comes 3 times, 2, 5 comes 3 times, that is in transaction 200, 300 as well as 400, and 3, 5 transaction comes 2 times. So transaction 3, 5 comes in 200 and 3, 5 comes in 300. So take these values and divide the value by 4, and you will check here again. There are certain percentage of support you can again obtain, but again the support which is less than 50%, you can delete that. So 1, 2 and 1, 5 will be deleted after that. That is why it is highlighted red. After that again you increase the number pair to be 3 values. So how much 3 values you can form is 1, 3. Because it's a set, you cannot form 1, 3, 3 because that will not be viable, because in set you cannot repeat values. So 1, 3, 5 you can form 3 values set, and then 2, 3, 5, that are three different value set, and another one is 1, 2 and 3. So these are the 3 values that you can form from the remaining points here. So there can be another values that can come here, so you can check and try every other combination that can be there, but these are the 3 main combination that can you form from the second step. So in the third step, now again check 1, 3, 5, these 3 items are coming together, where one time it is coming together in 300 transaction, yeah, so it again becomes 25%, and then it is 2, 3, 5 items are coming 2 times in transaction 200 and 300, so it becomes 2 by 4, that is 50%, and 1, 2, 3 is also coming only one time, so it becomes 25%. So only the remaining element from this particular part here is 2, 3, 5, because it has a support value of 50%, and 20-25% is less than the minimum support value, so you move on to the next part. So this is how it is set. Now you can just place all the sets together that are being shortlisted. So these are the 3 sets. So the first set we have shortlisted 1, 2, 3, 5. In the second set we have shortlisted 1, 3, 2, 3, 2, 5, 3, 5. In the third set we have shortlisted 2, 3, 5. So you just write the support values with it. So prepare a table. So write the support values with it. Now you have to generate the association rules. So how can you generate it? So just simply write the rules, the support, and you write the confidence. So how to do it is that you use the formula for it. So the formula is S of A exponent sign B, so divide by A, so it will give you what is A transaction, A exponent B is A is actually 2 and B is actually 3. So you place it, you will get the value here. So I'll tell you how to do it. First, identify that which particular part associate the maximum rules here. So only the part that is 2, 3, 5 has the minimum support value, and it has the maximum elements here, that is 3 elements with a support of 2. So it is able to generate the maximum support percentage of 50%. Now we will make the rules based on this only. So the rules will be 2 combined with the 3 gives you 5. So this is first rule. Another rule is again combination of these. 3 combined with 5 gives you 2. Similarly, 2 combined with 5 gives you 3. Now reverse that 3 can give you reverse it. 2 can give you 3 and 5. 5 can give you 2 and 3. 3 can give you 2 and 5. So this is how you form this, and you write the support as it is, the support value, because it is taken from the set 2, 3, 5. The support of this is 2, so you can set the support 2, 2, 2, 2, 2 from anywhere. Okay, so how is this first calculated? So how the confidence is being calculated? So check here. Now first, the formula of confidence is S of A B. B gives A by A. Then you just check here what is it. So it is S of 3, 2, 3 and then by S of 2, 3 equal to. So what it means is that what is the support of 235? 235 support is already given to you as 2, and what is the support of 23? So 23 support is also given to you as 2. Check here in the set. In the second step we have formed 2, 3. We have shortlisted from second set a pair, that is 2, 3. Its support is also 2. So 2 divided by 2 becomes 1, that is 100% confidence. Similarly, go for 3 and 3, 5, 2. Again it becomes 2 by 2. For any other part it becomes 66%. So whichever part you can shortlist here, if you set the minimum confidence value to be 70%, only the first 2 rules will be associated. So what it means is that 2, if you have bought the items 2 and 3, you will also bought the item 5. Similarly, if you have bought the item 3 and 5, you will most probably bought the item 2 as well. So this is how the association rules are being generated. Now if I go back to the example that we have seen in the R environment, so it is generating a similar kind of confidence rules and algorithmic specifications that are being mentioned here. So confidence level it says is 0.5, minimum value is set to 0.1, S max, ARM, eval, original value, and some of the algorithmic parameters are also mentioned here. So it says absolute minimum support count is 98. Moving on forward, now what the algorithm actually gives. So it generated the a priori algorithm in R generated around 15 rules with the given constraint, and min value is the minimum value of the support of the item set which should be satisfied to be a part of the rule, and S max generates the maximum support value, and AREM is the additional rule evaluation parameter, and we have fed support and confidence as the constraint. There are several other rules using the AREM parameter. So this is how you generate various rules by using the a priori algorithm, for which we have already seen how a priori algorithm works. So this with this your rule association rule mining is finished with in R, and thank you.